Okay, this is Algebra 2, Semester 2, study guide for quiz 10 and 7B. If you were not in class before spring break, this quiz will be given the very first day back. So make sure that you understand it. Come see me outside of class. If you have any questions, come see me before class starts. Here we go. Let's see. There we go. Let me get it in the viewfinder. Sorry guys, you're getting me better and better with this. Okay, here's what it says. Create the transformed graph for each function. Under the description, list the transformation, shrink, stretching, and so on. So here I look at this and I know that it's the square root. The square root of x, that was the parent function. And I say to myself, well, it is inside of that root symbol. If I remember back to the HK format for any of these, we have y equals plus or minus a, and then whatever symbol, it could be a cube root, a square root, whatever, minus h plus k. Now remember, or rewind this tape to keep hearing it, the plus or minus causes a reflection. If it's plus, it's just like the parent graph. If it's minus, it's reflected over the x-axis, so it flips it upside down. The a value, if it's an absolute value greater than 1, then it stretches it away from the x-axis. If it's an absolute value less than 1, and between 0 and 1, then it will shrink it down to the x-axis. The h value shifts it left to right, and it is opposite of than what it looks because of the negative here. The k value will shift it up or down. So here we go. The square root of x minus 4, I know that that's an h value. I know that it's reflected because of the negative there. Now the h value moves left to right, and it's opposite of what it looks to, the negative in the formula. So it looks like a negative 4, so it's going to be positive 4. So I come over to positive 4, 1, 2, 3, 4, and I put a dot. And normally the parent graph, remember, went up like that. Well, now this graph would go like that, except that it's reflected. So now it comes down underneath like that. So in the description, you want to tell the shift so it's reflected. And shifts right 4. The domain, there's no graph down in here. So the first point on the domain is right here at 4. So it would be x is greater than or equal to 4. Now you can write that a number of different ways. And you can look at your notes from class as to how you want to write it, all accepted in interval notation, in set notation, as an inequality, however you prefer to write it. Now the range is the y values. If you go along the y-axis, it could occur anywhere down in here, but the highest point that it occurs at is 0. So y is less than or equal to 0. Next one. This is a cube root. Remember the parent function looked like this. Looks like a square root, but it's able to have a negative value, so it goes both ways. Knowing that it goes forever both ways, we can already skip down to the domain and write in all real numbers. For the range, because it continues spread out both directions, we can also put all real numbers. And now we go to our shifts. That's an a value, a greater than 1, absolute value, stretches. So it's going to stretch by a factor of 3. We'll just go ahead and write it down here. Stretch by 3. Now, the plus 2 is not inside of the brackets with the x, so it's after what the effect on x is. Therefore, it's a k value, so it's up to. So we take the vertex right here at the origin and move it up 1, 2, and now we draw it the same as the parent graph originally was. Okay? Now we come down to this one. This is an exponential growth because of that 2. Now remember the parent graph across here at 0, 1, and then it was growing, so it went up like this, something like that. So now we see that we have a shift. That shift is not up in the x. If it was a h-value shift, it would be up in the exponent with the x. It is not that way, so we know that that's a k value. So it's simply shifting down 4. There's no other shift involved. That 2 is part of the parent function. So we just shift that vertex right there at 0, 1, down 4. 1, 2, 3, 4. And now we draw that again. Okay. In the original parent function, the restriction on the range was that it could not go below 0. So now this one, because we've moved it down 4, would be that y is greater than, not equal to, -4. The domain can go either way forever and ever, so it's all real numbers. In the rational expression for graphing, the parent function was 1 over x. That's when our asymptotes were right on the x and y axis. But now, if you look in there, that's an h value, so we're shifted 3 units to the right. So we come over 3 units to the right to draw our new asymptote. Label that as A of S. I just do ASY, I'm sorry. And now this asymptote stays the same. ASY. Okay, now you know the parent function came right in here down to just 1 square away. There's no other shifts involved. So you just go 1 square away from your asymptotes, right about there, and draw your wings. Right about there, draw your wings. I'm not requiring you to be real picky with those. The description on that is that it shifted right 3 units. The domain, remember on the hyperbolas, you simply tell me what it's not. Those asymptotes tell me what it's not. So x cannot equal 3, and y cannot equal 0. Okay, down to the bottom functions here. I'm wanting you to tell me the parent function for this. That is an exponential. Function. The equation for the parent function is y equals 2x, 2 to the x, I should say. The domain of the graph We can go forever and ever in both directions on the x-axis, so it's all real numbers. And the range for the graph, there's no graph down in here. We don't see graph until after we get past 0. So y is greater than 0. Okay. Next graph, a hyperbola, parent function is rational. Expression. The equation of the parent graph is y equals 1 over x. The domain, again remember, this is when we list what the asymptotes are, because x can be everything except for the asymptote. So x is not equal to 3, and y is not equal to 0. I'm sorry I gave you two of the same hyperbolas, and I didn't intend to do that. Now on the next page, you actually look at your limitations to get these. I'll just post the key to this. If you need help going through them, then let me know. The key is 1, 2, 3, and then there's 4, 5, 6, 7, 8, 9, and 10, 11, 12. Good luck with that, and be prepared to take your quiz on the first day back.